Hello and welcome to today's webinar presented by Dlubal Software. Today we'll be working in our finite element analysis software, RFEM. The topic for today's webinar is optimal BIM integration with Revit and RFEM. My name is Amy Heilig. I'll be one of your presenters today as well as moderator, answering any questions you may have. I'm the CEO of the US office and also a technical support and sales engineer, and we are located in Philadelphia, Pennsylvania. My colleague Lucas Suno will also be a presenter. He's a product and customer support engineer located in our Tiefenbach, Germany office. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within the same dialog box. If by chance I don't get to all your questions, I will certainly send you a follow-up email afterwards. So regarding the content for the next hour today, I want to go over the RFEM and Revit integration, and in particular, the import and export options available. We'll take a look at an example which my colleague Lucas will present. This will include a structure that begins in Revit. We bring this into RFEM. We update the model in RFEM. We bring it back to Revit. So we're going to include updating the model, whether that's all or partial, and the round tripping options to go between the two programs continuously. And finally, throughout his example today, he'll go ahead and give you some tips and tricks for optimized data exchange. So when we look at integration between two standalone programs, there's typically two different options, file-based versus direct link exchange. So when we look at a file-based data exchange, this is where data is stored in text files. It requires a standardized format, and some examples for this might be DXF, IFC, STP, and other file extensions. So within RFEM, you can see here for the export and import options, we have all of these different data exchange file extensions available. You'll see here STP, DXF, DAT files, and so on. So this does not require the installed applications. What this means is that both programs do not necessarily need to be installed on the same computer. Rather, we can take RFEM alone and create this data file and then import it into some other standalone program, whether that's on the same computer or a different computer. This is non-proprietary, meaning not any particular company owns this process, but rather this is a standard format for many standalone programs. We create these data files and then we can give them to colleagues or to other engineers to import or export into various programs. Now, the downside of this is that the applications do not interact directly, so there could be missing data. What I mean by this is, for example, nonlinear supports, load combinations. These are two items that are included in an RFEM model and are incredibly important to the design. Well, if we export our data to another program where nonlinear support definitions or load combinations don't exist, then we're going to completely lose that data when we're utilizing a file-based data exchange. Now, on the other side, we have direct link data exchange. This is where the applications are linked through APIs, or application programming interfaces. So with this, there really aren't any limitations to standardized exchange format. We don't have to follow the same guidelines as a DXF file or an STP file, but rather anything's possible with just some coding knowledge between the API interface. Now, this exchange does require the installed applications to be on the same computer. So, for example, today when we're looking at Revit and RFEM, both programs need to be available on the program or on the same computer in order for the exchange to take place through the API interface. With that said, though, the trial version for RFEM is still available to do full import and export to Revit. So the engineers that have joined us today that don't necessarily have purchased a license of RFEM, you can download the 90-day trial version and still explore the data exchange with Revit. So although both applications have to be on the same computer, it does still work with something like the trial version. With this option, the applications talk directly to each other. So with this, we're going to see a lot less limitations with object inclusion. So back to my previous example with nonlinear supports and load combinations, well, now we can just code in the option through the API interface to keep this information available. So whether we're round tripping between the programs, we'll never lose that information, even if it isn't necessarily included in the program that we're interfacing with. So this leads us to the Dlubal Revit link and the import-export options available. So I want to first note that this does utilize direct integration with API. So again, we're going to see a lot less data loss than when we're creating a data file format. This option is included in RFEM. So for those of you who are not familiar with our programs and how they work, we do operate with the add-on module system. So RFEM is our main program. This provides us with a full analysis. Our add-on modules are utilized for design, for example, or dynamics. Well, the import-export options with the Revit link are all included in the main program, and this is at no additional cost. The ability to integrate between the two programs is bidirectional. So we can update all or only partial of the structure and continue to cycle between both programs continuously. You can transfer the structure objects. So we can see here from our dialog box to import-export in Revit directly the ability to turn on or off these objects. We also have the ability for the transfer of loads and load combinations. So in our next tab, the structural settings, again, you see the ability to turn on and off those load cases, load combinations, result combination options. And lastly, with regards to result sharing, we have the ability to export the RFEM results to Revit. This includes both members and surfaces. So we're going to see the information available for deformations, internal forces for those members and those surfaces, and reinforcement, for example. Now, we've had the ability for a while to transfer reinforcement of surfaces, so whether that's walls, elevated slabs, slab on grades for concrete design from RFEM to Revit for quite some time, but we also recently added reinforcement for members. This is important because this allows us to now collaborate with other colleagues within our office or other engineering firms. For example, for the reinforcement, if we wanted to include this on the Revit drawings, we now don't have to manually import in this Revit or these rebars into our Revit drawings, but rather we can bring in what RFEM has designed for us directly into Revit without any additional information. This also can be used for further design. So there are tools within Revit, for example, that will do a further design, but we need those internal forces from the analysis. Well, we have that ability to import in internal forces as well. So with that said, that gives you a brief overview of the import-export options with the Dlubal Revit link. I want to turn it over to my colleague Lucas now, who will take us into an example between the two programs today.
Okay, thank you very much, Amy, for the introduction and the overview. I think you should be able to see my screen, and yeah, should be possible. Hello also from my side. In the next 45 minutes, I would like to show you the interface in action, and during that, I would like to highlight a few different scenarios Amy already mentioned. The first scenario will be one where we have a structure ready in Revit, and we want to export the data from Revit into an empty RFEM model. Therefore, I would like to show you now the Revit structure. Maybe as a side information, I'm using here Revit 2019. We do, however, support the interface down to Revit 2016. Regarding the structure itself, I have here a mixed structure made of concrete and steel. I have a foundation slab. I have some walls with openings. I have curved walls, as you can see here in the corner. I have slabs with openings, concrete columns, and 2 steel constructions on top. The one on the left side has a curved roof shape, and the one on top has a sloped roof shape. What you cannot see here right now in this Revit model, or what I did not include, is basically everything apart from the static relevant objects. So objects like, or things for heating, cooling, ventilation, electrical systems, any kind of building services. You can have all those things inside the Revit model, of course. They're just not important when it's about to show the interface to RFEM. Important for the interface is the analytical model in Revit, and how you can get this analytical model I will show you now. I think it's fair to say that what we have here is the physical model. It's the solid representation of the structural elements. So everything here is basically a solid. The foundation slab, the column is a solid, the slabs are solids. But when it comes up to the analytical model, we usually try to simplify things. So for example, the foundation slab, we usually would simplify into as a 2D surface, or the beams we usually consider as a 1D element. And this simplification can be done in Revit directly. If you click on the structure element, you can access the properties here on the left side, and you can enable the analytical model. It has already been done here by me in advance. And if you do so, you will get an additional tab for the analytical foundation. Here you can edit now the properties of this analytical foundation. So you can, for example, assign a surface support below, or you can deal with the analytical alignment of this 2D surface. Similar options to that you have also for walls and other elements, structural elements, for example, also for beams. Depending on the object you select here, or depending on the analytical object, you maybe have different settings you have to deal with, or you can deal with. So for example, we have here as well the analytical alignment of the member axis, but we have also an option to define member end releases in Revit. Additional to this, and this is now a little bit Dlubal specific, it's Dlubal parameters that I activated in advance. I have here an option to define this analytical member here in the background as a member type truss. Or for my bracing here, I can define it as a member type tension. This is an information which we can exchange with RFEM or with RSTOP, and I will explain it afterwards again. Okay, so by activating the analytical model for each of those elements, you can create the global analytical model. And this you can also, of course, see in Revit. Revit has here a predefined 3D view, which we can activate. So again, this is the analytical model. This is what we will export afterwards to RFEM. And you can see what I just mentioned. The foundation slab is now a 2D surface. Also, the beams are now just, or the members in general are now just a 1D element. So in general, I think it's clear that when we export the analytical model, the geometry is quite clear. It's fixed. It's defined, clearly defined by the length and the height of the elements. What's maybe not so clear is the exchange of information. And with information, I mean the exchange, for example, of the material names, of the cross-section names, and so on. I think in general, you can imagine that the material names in Revit are maybe different to the name of the material in RFEM. So how you write the name can be different. maybe I can show you one example here. I go to the Manage tab into my material library in Revit. And here here you will find a material which is named concrete normal white 4 KSI. This is the material that I used for my concrete elements here in the background. If we would export that name to RFEM, RFEM probably couldn't handle it. It doesn't know what kind of material that is, because the name of the equal material in RFEM is different. So we somehow have to link this information between those two programs. We have to define this, something like a conversion table. And there are two ways how we can do it. And the first way is actually something like a conversion table, or it is actually a conversion table. It's a table where you define on the left side the name of the material in Revit, and on the right side the name of the material in Dlubal. And if you export the model from Revit to Dlubal, or the other way around, it will check this table, and if it will find a match, then it will use it, of course. The same also for the cross sections. The other possibility to link these information is via Dlubal parameters. So you can define directly in Revit the name of the material in Dlubal. This is also something which I can show you in my Revit model here, because I did it actually that way. So as I just said, I'm using this material here in my Revit model, and via these custom parameters, here in that window, I was able to enter the name of my Dlubal material. So instead of exporting this name to RFEM, we will export this name. And since this is the name of the material from the RFEM library, we will get the correct material parameters and the correct values for the design which we have to do afterwards. Okay. Apart from that, we can also see that some loads inside this analytical model. So we see here that there are some loads assigned to my members. So Revit gives me the possibility to define load cases, load combinations, and even loads. You can access this information via the Analyze tab, and you can click here on the load cases, and you can see we have here 4 load cases for the dead loads, live loads, wind loads, and snow loads. And all these information I can exchange now to, or I can export now to RFEM. And I think this is something we could do right now. So how can I do it? First of all, I will show you my empty RFEM. There's nothing inside. And I can start the export from Revit. So I have here a Dlubal tab. And I have here options to export and import between RFEM, export and import to RSTARP. And here I have some additional buttons. Here, for example, the one which we call Dlubal parameters. This is what I just explained. We have parameters for the materials, for the cross sections, for these special member types. Here you can activate these parameters in Revit, so you can access them here in these windows. So I want to export my model to RFEM. Therefore, I export this model. I can define some detailed settings for the export. I can define the set direction of my RFEM model. It should go upwards. I want to create a new structure in RFEM. I want to apply some eccentricities that I have here inside my Revit model. And I also want to use these cross-section and material parameters that I just defined. Additional to that, I can also export my loads. I can run the export. And you will see that it's quite quick. Yeah, the export is already done. So I can close this window. I can open RFEM again. And you can see directly that the structure we receive here on this end looks quite similar to the one in Revit. We have the foundation slab as a 2D surface, of course, including some supports. We have our walls with the openings. We have this curved wall here on the edge, or in the corner. We have concrete columns. We have steel constructions here on top, the one on the left with the curved roof shape, the one on the top with the sloped roof shape. Yeah, looks quite good in general. But if you exchange data, you always want to make sure that you exchanged the data correctly. So we should have a detailed look on this data. And there are different ways how to do it, and I would like to show one way. And the one way I would like to show you is by using the display navigator here on the left side. And here I have an option to render my objects according to different colors. So for example, I can render my structure according to my materials. We haven't seen any difference now because it's basically the default rendering option. What we can see here is that every gray element is basically made of concrete and every blue element is basically made of steel. We will see an effect if I change it to rendering according to cross sections. Yeah, thank you. We see here that the cross sections are now colored, and the color represents a specific cross section. So this allows us to get a nice overview about the structure and the exported sections from Revit. We have further options here, for example, the member type. This is something I wanted to explain again. You can see here that we have different member types. We have member type beam, truss, and tension. And this is what I defined in Revit before. We said the coupling member should be a truss member. And we also said that this bracing should be a tension member. And this is an advanced information for RFEM. This basically means a truss member is a member with hinges at the beginning and the end. And a tension member is a truss member plus that a nonlinearity is assigned to that it should fail under compression. So these are additional information or advanced information that you can exchange between Revit and RFEM or Dlubal in general. Okay, there are further options, for example, the rendering according to surface thicknesses and so on. And there's one which I also want to show you. It's according to member hinges. What you can see here is now that there's no color included in this graphic. That tells me that there is no hinge included. So I have no member hinges here in this structure. What that means that every connection here in the steel construction is a rigid connection. And as a structural engineer, this is something you want to avoid. And of course, we can add these member hinges here in RFEM as well. So what I'm going to do is now following. I will define one type of member hinges. In that type, I want to release the rotations around the Y and the Z axis. And now I can assign this member hinge graphically to my RFEM model. Assign graphically to members. The only thing I have to do here right now is selecting these members. Depending if I select the end or the start or the center of the beam, I will apply this member hinge to the end, start, or on both sides. Okay, let me just double check if I did it correctly. Yeah. I could even double check it by this graphic, which we have still activated. You can see now, I have now one member hinge here, and the blue color will show me on which side of the beam I defined it on. Okay. So with the display navigator, we can double check, for example, the imported data. We assume the model data is now correct. So I want to continue with my loads. I have here 4 load cases. These are the 4 load cases I expected to have because I imported or exported them from Revit. And I can also take a detailed look. I have some dead loads, additional dead loads. In this load case, I have some live loads here on top of the slabs. I have some wind loads and also some snow loads. I can see directly that the person who created the loads in Revit forgot the snow loads, for example, here on this steel construction. Again, this is something I can, of course, also add in RFEM. Therefore, I'm going to use a small generator. I will generate some loads from area loads on members via plane. So I'm defining the magnitude of these loads, 0.02 KSF. They should be related to the global projected area. And I can pick the corner nodes of my area where they should act. I will simplify it a little bit here for the presentation, just that we save a little bit of time. So I'm picking these corner nodes and I'm cutting a few edges, I know, but yeah, should be okay for now. I want to remove the influence from all horizontal members because I want the load to be applied only on the slope beams. Okay. So this is what I receive. After I did that, I can see my area load. I can also change the display and display it separately as member loads. The intelligence of that generated load is still active, as you can see. So it's still in generated load. And this is an advantage for something I will show you afterwards. Okay. I don't want to deal with the loads any longer. For now, it should be okay. So the next step would be the combination of these load cases. This is something I can do in RFEM as well. I go to my general data. I will enable the automatic combination of load cases according to the ASCE code, and yeah, create load combinations automatically. I want to control this automatic load combination a little bit. Therefore, I'm checking the related tables. First of all, I want to make sure that the correct action category is used for every load case, which is the case here. In case we would have multiple load cases in the same action type. So in case we would have multiple wind load cases, for example, I could control here in that area that they should act simultaneously or alternatively or in groups or whatever. Another important information which we have to give to this automatic combination is according to which design situation it should create these combinations. So there is the LRFD section, the ASD section, extraordinary, structural integrity, and so on. And every design situation has its own rules how you have to combine load cases to, which you can see here. These are the rules according to the LRFD. These are the rules according to the ASD. You have different factors here and a different setup in general. And depending which design situation you create here, you will have additional load combinations, of course. I want to save a little bit of time, so I'm deactivating the ASD combination. I only want to have combinations according to LRFD. I will create these combinations here. I can have a look at them again. I can see the factors, so I can control it or double check it. Additional to this, I get a result combination. A result combination is like an envelope for all load combinations. It will show you, if you take a look at the results of a result combination, it will show you the maximum and the minimum and its related internal forces. Okay. You can access or you can switch between the load combinations via this drop-down menu. So before we run now the calculation, we should have at least a rough look at the, a look at the finite element mesh. It's a finite element analysis here, so the finite element mesh has a huge effect. So what I will do is I go to my FE mesh settings and I will only define the target length of my finite elements. This is the most important information for now. I will regenerate the mesh and I can see the finite element mesh now. In general, you could say it looks quite good. I mean, it's decent. There are some areas where it's maybe not so optimal. For example, here on the right side, where I have these openings inside, the windows inside, I have just two elements between the edge and the opening, two elements. This is maybe a little bit too less, or this is not enough elements. So I want to optimize that area. Let's say just this area here. How can I do this? I just double click on the surface. I can go to my FE mesh tab and activate a FE mesh refinement. The only info I have to give here is the target length of my finite elements in that area, maybe 0.5 foot. I accept and optimize that also on lines or on nodes. I will do it also for the node here. So around this node, I want to have an FE mesh refinement. I go to the tab, I activate the FE mesh refinement, and I can define additional information about the radius and the target length inside. Okay, we assume we optimized the FE mesh of the structure for every section. I will skip it here right now, and we regenerate the FE mesh. You can clearly see the effect now. So this is the global FE mesh. This is the refined FE mesh. You can see the effect as well here around the column. It was quite easy to change that. Okay. So the next step is basically the calculation of the internal forces. I will do it by selecting my result combination here, and I will say, please show me the results of this result combination. I will do it, or I do it in this way, or I could have also done it in a different way. I could have clicked on the button calculate everything. But what does it mean? It will calculate also the results of my load cases. But I'm not really interested in the display of internal forces of my wind load case where there is no self-weight acting. So to save a little bit of time, I just clicked on the results of this result combination, and the program is intelligent enough to calculate only the required load combinations. Okay, we will see the results in a few seconds. And then we can continue with the design of the structure. Okay. For some reason, it takes a little bit longer than when I prepared it, but that's okay. Okay. For the calculation finished, we will see the results in a second. And I can switch now again between my combinations and display for each combination my result. Let me decrease a little bit the display factor, otherwise it looks like the structure is failing. On the left side, I have my result navigator now. I can switch between deformations or member internal forces. So for example, you can see really nicely that the axial force in the columns will be increased every time it intersects within slab, of course. I can also display some bending moments, maybe to double check if the hinges I defined are correctly or work correctly. I can, of course, also take a look at the results in my surfaces, maybe some bending moments in my surfaces, or even the contact stresses on the foundation plate. on the bottom. With the design of these internal forces, we are not done, or with the calculation of these internal forces, we have to design the structure. That means we have to do additional checks, stability checks, stress checks, and so on. And these additional checks can be done in additional modules or other modules. And I want to go over this topic rather quickly because Amy has some really nice webinars where she explains every module in detail, or the most common modules in detail. So one module which I want to show is the module RF Steel AIC. It's for the design of steel members, and this is what I'm going to call up now. You will notice that every module looks more or less familiar. So if you know how to handle, if you can handle one module, you most likely can also handle the other modules in general. So what I have to do is I have to select the members that I want to design. I only want to design here this beam and this column, for example. You can pick the code you want to design according to, and also the result combination. You have now additional windows that you can go through. Some of them are just to give you an overview about certain properties for materials or cross sections. Other windows deal with the stability checks of the beams. So for example, you can define intermediate lateral restraints, you can define the buckling lengths and so on, or the design parameters. I will leave those values on default. So I will run the calculation and I switch into my result table design by cross section. So what I see here is for each cross section that I designed the maximum checks. And I notice directly that the W section for the beam has a design ratio about 1.12. So it's higher than 1, which is not good. On the other hand, the design ratio of my column is not even at 10%. So I have to optimize both cross sections somehow. And I can do it the following way. I can go to my cross section window again, and I could, for example, let the module optimize the pipe section automatically from the current row. Current row basically means following. It will look for the best section in this list here. And with the best section, I mean the section where the design check, the design ratio is smaller than 1. And if there would be, and the criteria for this optimization is actually the self-weight of this section. Okay, wait, I did a small mistake, sorry. Import cross-section from RFEM. I changed it, which I didn't want to. I want to optimize the cross-section, and I could, in general, do the same for the W section, but due to constructive reasons, I'm not able to change the section. So what I'm going to do here is I'm going to apply additional beams in my roof. So I just select the beams, and I use drag and drop to copy them. It's like a graphical tool to copy beams, and it's really quick and easy. And by defining additional beams, I will spread the load. And this is something what I want to show. If you remember, we defined here this generated load where we defined the area where it should act on and so on. And this load is so intelligent that it recognizes these new members, and it will redistribute the area load to all beams now, to all slope beams. And this basically means that the load on the beam we design will be reduced. So I go back to my module and I rerun now the design. So for the pipe section, I'm using an automatic optimization, and for this section, I optimize the analytical structure in the background. I click on calculate again. And yeah, of course, I have to recalculate now the internal forces simply because I changed analytical model in the background. I added additional beams, I redistributed my loads, so I have to rerun the analysis. Maybe one side information while we are recalculating this. Maybe something I can show you, the task manager. And in the task manager, you can see that I'm using more or less 100% of my CPU. That means we are able to use all the physical cores from the processor or from the CPU. So in case you have a good hardware, it will definitely benefit the performance during the design or during the calculation here. Okay, yeah, we have to wait a few seconds more and then I'm done with the design. Okay, this should be the last one. We will see again we will see our result tables again. And in these result tables, we will see now that the design ratio of the W section is at 66%, which is fine. And the design ratio of my pipe section is at 94%, which is also fine. So to make it 100% perfect, we would actually have to redesign everything because the design of my pipe section, of this optimized pipe section, has been done with the internal forces of my original structure. So what I would have to do is I would have to export this cross section back to RFEM, the optimized section, recalculate my internal forces, and with these probably slightly different internal forces, I can rerun the design. I will skip this check right now, or this loop. Of course, we are able to display the design ratios also graphically. I think this is no big question. Okay, so we just changed a lot of stuff in that top steel construction here. We added hinges, we changed the amount of beams, and this is maybe something which you would like to give back to the Revit model. So you want to update the Revit model with this information. And the way you can do it is following. You go back to Revit and you run the import from RFEM. You update the existing structure. I don't want to consider any eccentricities right here, right now. I want to apply loads, that is okay. And I don't want to import any results right now. Just update the physical model. So I can start the import and you can have a look at this area here. Okay, so first of all, we get a message about an unsupported combination criterion. Basically, Revit tells me here that it cannot handle result combinations. It's not a big deal here. Important is that we have now these additional beams in the roof. And we also have updated information in the analytical model. So you can see here in the properties that we have now also information about the hinges on the bottom of this column and also in the beams and everything. So we were able to update the analytical model in Revit, and we were also able to update the physical model. We added new beams here. Okay. The next step, or the next thing that I want to show you, is also the design of some concrete elements. So I don't want to, I want to design the columns, and also there's a beam inside, which I didn't show you before. So there's also a beam, and I want to design these elements in RFEM and also export this result into Revit. So I go back to RFEM, and to design these concrete elements, I need a different module. This module is called RF Concrete Members. And it looks familiar, you can already see it. You simply have to choose the design you want to do this, the code you want to design the concrete members according to, and the load combination again, or the result combination in this case. And then you have again additional windows for the material, for the cross section, reinforcement layout windows, so like which rebar, possibly rebar you want to use, stirrups, the concrete cover, and so on. Again, Amy has some nice webinars about this module, which you can take a look at. The only thing which I want to change here is the members I want to design. So I'm clicking on basic, or I'm selecting here all the columns from the highest concrete level and also the beams here in the background. Okay, I will run the calculation. Since I already have the results from my result combination, I only have to do the design of the beams, and it's quite quick. So I get now additional tables for my results. I have here information about the required reinforcements on top, on the bottom layer of the section, for the shear, and so on. And this module also gives me a provided reinforcement. So here I have some nice drawings, and I can also display this provided reinforcement in my RFEM structure. So I can choose here the concrete case, and I can display the results, and I can enable the reinforcements rendering. So I will zoom a little bit in, and you can see directly I display here now the rebars inside my concrete column. And this is also working for beams, of course. Here you can see the stirrups and the longitudinal rebars in the beam, including the hooks. And this is also an information you can export it. This is a quite new feature. So I can go back to Revit. I can import the model or import the results from RFEM. I will take a look at the settings here right now. So I'm not interested in results. I'm interested in reinforcements settings. I want to import the reinforcement, not from surfaces, but from members, because I designed members here, and I can run the import. So this is again the log basically, which he will show us. And after the import, we do get, okay, the same message again. I don't care here in that moment. But we also get a new 3D view, and this is called 3D reinforcements. And by default, the reinforcements will be displayed as wireframe model. If you switch up a few visibility settings in Revit, so for example, you have to change the visibility for the rebars in that specific view as unobscured object and view as solid. And then you can also change a little bit the display of the structure. You will see the rebars also in a nice solid model here in Revit. So you can see again the stirrups, you can see the longitudinal rebars in the columns, and also in your beam. And these are not simply graphical objects. This is actually a rebar. So if you click on this object, on the stirrups for the column, for example, you could change now the shape of the stirrup. You can change the hooks. You can change the quantity of stirrups in that column, and so on. So it's an actual object you can work with. Okay. This would be the first scenario that I wanted to show you. So the exchange between RFEM and Revit and using the global model, so the complete analytical model. And you could theoretically continue here. You could change or update or add additional things in Revit. You can update the RFEM model. You can design again the RFEM model and export these newly found results or anything else back to Revit. So back and forth, and this is what Amy said, it's a bidirectional interface. But not in every situation you want to export the complete analytical model. It's not always required, and not every engineer actually wants to work with big 3D models. Some prefer to work with smaller models, or they want to design it level by level, for example. And this is something I would also like to show you. You can export partial models from Revit to RFEM. And I did it in advance for this small structure here on top, for the steel structure. I can show you. So I have here this pavilion. It came from Revit, and I calculated and designed it, and I have some support forces down here. And now I want to do it for the concrete structure below. So I would like to do it basically for the following elements. So for the concrete walls, for the concrete slab, and the concrete columns in that level. So I select those objects here in Revit. I go back to my Dlubal tab and I say export model. I can create a new structure in RFEM, and I export only the selected objects. You can also do it via visibilities. I prefer here selected objects. I want to apply my member eccentricities, use my Dlubal parameters again, and also apply the loads. So I run the export. It's done. I can go back to RFEM. You can see here this partial model from Revit. So just the concrete elements from the top floor. And you can work with this, of course. You can support the columns with nodal supports. You can assign line supports onto the walls. And we also received here, or we also imported the load cases from Revit. So we have here the live loads on top of the slab. We have some wind loads and so on. But we do miss now the loads from the structure which we have on top, you know, the pavilion, the support forces. But there is a nice tool in RFEM, and you can call it up via the tool tab, the menu tools, and you can import support reactions as loads. So I will click on this option. I can choose the file, the pavilion that I designed before. I can say, please import me the support reactions from all supported nodes from any load case that I calculated in there, for example, load case 1, and please place these loads on top of my slab. Okay. You can see here now that we imported for every the support reactions from every column from the structure on top. And maybe you want to double check the values. We have here 2.1 kip. And if I go back to my pavilion, I can see here, this is the support reaction from my dead load case. And with this workflow, you can actually import the support reactions from every load case from the structure on top. And since we imported also the load combinations already, we can use it and redesign the structure. Maybe I can show that quickly. For the slab here, I can call up the module which is called RF concrete surfaces. So to design concrete surfaces such as the slab or the wall. Again, it looks familiar more or less. I will use here just the combination 3 now, according to the ACI standard. I will tell this module, please design me now only this concrete surface here, the concrete slab. And calculate the required reinforcements for this. This is what it will do now. I get now result tables with required reinforcements information, and I can display this also graphically, of course. So in my result navigator, I can display now the reinforcements on top, which is now higher in the area of my columns, or the reinforcements on the bottom, which is of course higher between my supported nodes. And these results I can also export back into my Revit model. So what I can do now is I can go back to Revit. I can import results. Let me just check a few settings here. So I want to import now results from result values from my concrete case. No reinforcements, because we didn't calculate any reinforcements there. We calculated required reinforcement values. So I import these values. I can click here on results from surfaces. Maybe all these results I want to import from the required reinforcement, and I can choose the source I want to import it from, which is this concrete case I just defined. Okay. I run the import. And what I will get afterwards is I will get a new 3D view here on the left-hand side. And as you can see, I imported now the values into my RFEM model, including this navigator here on the right, this color scheme on the right. I can even switch between my results, because this is now just the reinforcements on top, you know, in the slab. But via a result explorer, I can even switch between my results in that view. So I can say, please display me also the reinforcement in the bottom of my surface. If I click on apply, this view will update, and I can see the bottom reinforcements in my slab. So this is something that we just saw in RFEM before, right? So we can not only import here the rebars, we can also import result values from concrete modules, from internal forces, and so on. Okay, so this was the second scenario that I wanted to show you, that you can work with partial models. You can extract partial models and also update again the global model in Revit. And the last scenario, which is even shorter to explain, is following. I will close every model that I have here in Revit. So there's no model open. I will also close a few models which I have here. So this one and the pavilion as well. So it should only remain this global model that I imported before. And I can do also following. Imagine there's a structural engineer who designed this mixed structure here, and there's an architect who has to create some drawings and whatever in Revit, and he's now requesting or he's now asking for any information the structural engineer can give him about the structure. And the big benefit of this interface is that you can also export the analytical model in RFEM to Revit. So you can do it the following way. You create a new model in Revit. You pick on any template you have here, and you can go to the Dlubal tab, and you do what you just did, more or less what we just did before. We import the model from RFEM, and we apply member eccentricities. I skipped the loads. We could also import the loads, but I'm not doing it right now here. Try to keep it simple, and I can run the import. And then following could happen. It could be that Revit is asking you, if you could assign a Revit type for this type of section here. So there's a column in RFEM, a round hollow core column, a pipe section, where Revit doesn't know how to deal with it. Now you could think, we defined these conversion tables, and there is actually the information inside. The Dlubal cross-section round, HSS, blah, 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 should be the following section in Revit. But this message here is actually a completely different issue. The issue here, which we have here, is that the template that I used has no information about the family for this section. So Revit is a family-based software. You have to create families for sections and for any element that you want to model. And if this family is not loaded in this project, then we cannot link between these two elements, between RFEM and Revit. So what you would have to do in this case, you would have to load this cross-section from the Revit library. And this you can do this by following way. You click here on that arrow, you go to load family types. Then you can download some libraries from Revit, from Autodesk directly. For example, the US Imperial libraries for structural columns made of steel. And here you will find this pipe section that we are looking for. 5 times 025. Wait, I'm out too high. This section here, I can load it, and then I can apply this section. The import is running now. I'm still running, by the way. Okay, import succeeded. I can close this window, and I can take a look at my 3D view in Revit. Maybe change a little bit the visibility mode here into the shaded mode. And you can see we were able to import a structure which looks quite good. And we have here the sloped roof, we have the openings here everywhere, and so on. So we were able to import a physical model from the analytical model in RFEM. Of course, we were also able to import the analytical model as well. But the big pro here, or the big benefit, is that we get the physical model in Revit. And this is now something what the architect can work on. He can adapt it. He can maybe even export it into different formats to exchange it again via IFC, via step whatsoever. So it's really a big benefit, this third scenario, that you can create models in Revit from the data in RFEM. So this was most likely the content that I wanted to show you. I hope I was able to show you some new features or some interesting features. And basically you can take back the screen, Amy.
Perfect. Thank you, Lucas, for that informative example. As always, we know that was quite a bit of information. You can always find more information on the Dlubal Revit link on RFEM or any of those design add-on modules on our website, dlubal.com. We always encourage everyone to follow us on our social media sites. For example, our YouTube channel has all of these previously recorded webinars similar to today available to you to watch for free. Newsletters, events, and conferences, our knowledge-based articles, which includes technical articles and tips and tricks, are all available on these sites as well as our website. Our email at our Philadelphia office is info-us@dlubal.com. Our phone number here is 267-702-2815. So if you have any questions about today's webinar or any of our software products or anything in general, feel free to either shoot us an email or give us a quick call. We will have many more upcoming webinars in 2019. You can register on our website at dlubal.com under support and learning and webinars. As most of you know today, I typically send out an email letting you know when an upcoming webinar will take place, and you can register directly through the email as well. Now, something else that is a little bit different for this webinar than what we've previously had in the past regarding PDH certificates. The PDH certificate will now automatically be emailed to you, so you no longer have to request that through our email. So again, that will automatically be emailed to all participants. I will go ahead and check to make sure that people were present for the full presentation. Of course, plus or minus a few minutes is not a big issue. If there were additional attendees that watched this presentation under somebody else's registration link, or maybe you had several colleagues join you on one computer or screen to watch this, no problem. If they're needing PDH, then that's when we will need them to request this at info-us@dlubal.com. Again, for additional attendees who did not register individually, please request it at info-us@dlubal.com. Otherwise, you can expect to receive the certificate within the next day or two. And with that said, I want to thank everyone for attending today. And as always, we hope to see you at the next webinar. Thank you.